Hello everyone, welcome back to my YouTube channel. My name is Lokesh Koda. I am student of Shivanteshwara College of Engineering. Subject ADA. Topic Dynamic Programming. Dynamic programming is a general algorithm design technique for solving problems defined by recursive where overlapping subproblems. Invented by American mathematician Richard Bellman in the 1950s to solve optimization problems and later assimilated by CS. Programming here means planning. Main idea: set up a recurrence relating a solution to a larger instance to solutions of some smaller instance. Solve smaller instances once. Record solutions in a table. Extract solution to the initial instance from the table. Divide and conquer. Divide and conquer method for algorithm design. Divide. If the input size is too large to deal with in a straightforward manner, divide the problem into two or more disjoint subproblems. Conquer. Conquer recursively to solve the subproblems. Combine. Take the solutions to the subproblems and merge these solutions into a solution for the original problem. Divide and conquer example. For example, merge sort APR. If P greater than R, Q, the subproblems are independent or different. Dynamic programming. Dynamic programming is a way of improving on inefficient divide and conquer algorithms. By inefficient, we mean that the same recursive call is made over and over. If same subproblem is solved several times, we can use table to store result of subproblem. The first time it is computed and thus never have to recompute it again. Dynamic programming is applicable when the subproblems are dependent. That is, when subproblems share subproblems. Subproblems. Programming refers to tabular method. Difference between DP and divide and conquer. Using divide and conquer to solve these problems is inefficient because the same common subproblems have to be solved many times. DP will solve each of them once and their answers are stored in a table for future use. Dynamic program versus recursion and divide and conquer. Divide and conquer dynamic programming partitions a problem into independent smaller subproblems. Dynamic programming partitions a problem into overlapping subproblems. Divide and conquer doesn't store solutions of subproblems. Dynamic programming stores solutions of subproblems, thus avoids calculations of same quantity twice. Divide and conquer top-down algorithms which logically progress from the initial instance down to the smallest subinstance via intermediate subinstances. Dynamic programming bottom-up algorithms in which the smallest subproblems are explicitly solved first and the results of this used to construct solutions are progressively larger subinstances. Elements of dynamic programming. DP is used to solve problems with the following characteristics. Simple subproblems. We should be able to break the original problem to smaller subproblems that have the same structure. Optical substructure of the problems. The optical solution to the problem contains within optimal solutions of its subproblems. Steps to designing a dynamic programming algorithm. Characterize optimal substructure. Recursively define the value of an optimal solution. Compute the value bottom up. Construct an optimal solution. Principle of optimality. The dynamic programming works on principle of optimality. Principles of optimality states that in an optimal sequence of decisions or choices, each subsequences must also be optimal. Thank you.